channel. Let's do that. Screen share. Okay. All right. We are doing the second half of 1.2. We are going to talk about transformations with absolute value functions and quadratic functions. So something that I want to kind of bring up here is we're starting right here in notes. So you should be right here. Okay. This is what we're used to seeing. You know, when we've got our A on the outside in front of the parentheses, a vertical compression, this would be like a fraction. And that is something, a fraction makes a graph wider. And then like a whole number, like a 2 or like even a -3 or a 4. The negative sign just means that it's downward facing, but you know, 2, 3, and 4 whole numbers, that's called a vertical stretch. It gets narrower, remember? Then this right here, this is very rare, where inside the parentheses or inside the bracket is the A value, and it's multiplied by the X. So we're going to talk about it with 2 examples today, but it's not common. You're not going to see it a lot. In that case, I'm going to write at the bottom. A stretch means that the points get further away. A compression means that the points are closer. Okay? So when you see this, y equals the function where the A is inside the brackets, that's a horizontal change. And the X value in my ordered pairs gets multiplied by the reciprocal 1 over A. So the reciprocal of A, the X value gets multiplied by the reciprocal 1 over A. And the graph gets closer to the y-axis. This is only happening when the A is inside, when there's a number in front of X in the brackets. So again, it's rare, but we are going to talk about it today because it does exist, you know? I'm waiting. I'm going to turn the page. So here we are. An x squared is a parabola, right? The 3 that you see, I had, sorry. The 3 that you see is going to be a stretch by 3. So that's what the 3 does. That's the A, right? So we know that our quadratic parabola table of values parent function is this. And it's, think about it, x squared. This is just the parent function. Y equals x squared. 2 squared is 4. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So that's easy to even do in your head. But when I'm given a 3, I'm going to actually change my table of values, and my ordered pair is going to be x comma 3y. I multiply the y values of my parent function by 3. So let's look at that. The x does not change. -2, -1, 0, 1, 2. However, my y value gets multiplied by 3. So that's like 3 times 4 is 12. 3 times 1 is 3. 3 times 0, you get it, right? 3 times 1, 3 times 2. Oh, 3 times 4. Well, sorry. So I'm going to graph both of these. I want you to do colors, you guys. You know how I always do colors? I want you guys to do colors too. So 0, 0, oh, I'm sorry, -2, 4. -1, 1. My vertex is 0, 0. Let me get in there for you. 1, 1. 2, 4. That is my parabola parent function. Okay, and that's easy. So now, this 3, remember a 3 makes my graph skinnier, narrower. Check this out. From the vertex, my vertex is still 0, 0. I didn't have any transformation, but I'm going to go 1 in either direction and then up 3. So I'm starting at my vertex. I go 1 in either direction and then I go up 3. And then from my vertex, I go 2 in either direction and up 12. So this is all from my vertex. 2 in either direction. 1, 2, and up 12. That's way, I mean, I don't even have room. So my parabola is something like that, more narrow. Don't get confused and think that you have to graph the ordered pair -2. Well, because the vertex at 0, 0, it works out great. This is the ordered pair. But once we start getting into transformations, these new ordered pairs won't be located on the graph. Like example 11 and 12 that we're going to get to, you'll see. Okay, number 8. This is still a parabola. The 1/2 means it's a compression by 1/2. So write out your table of values that you know for a parabola. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And again, what's going to happen is this 1/2 is only going to affect the y value. So I'm going to get, I've got to multiply my y values by 1/2. The x values don't change. See how the x is still x? I'm doing no changing here. -2, -1, 0, 1, and 2. Okay? Then my y gets changed by 1/2. So 4 times 1/2. And let's do some volunteers just to kind of get this a little more, this is easy. So Caitlin, 4 cut times 2. Alyssa, 1 cut in half. -1 cut in half.
1/2.
Or 1 cut in half, 1/2. Phoebe, 0, half of 0.
0.
Yeah. And then obviously it's the same. Karina, half of 1.
1/2.
Yeah. Diana, half of 2.
1.
1. Okay, so let's graph first the parent function in pencil. 0, 0. Remember, from my vertex, the parabola goes 1 in both directions, 1 up. It's right here. 1 in both directions, 1 up. And then 2 in both directions and 4 up. 2 in both directions and 4 up. Make it curvy, it's a parabola. So for participation, I'm only looking for 1 point a week per person. Okay, so if you already volunteered like Tuesday, you won't be able to volunteer until next week or today. If you already volunteered today, I'm looking for new people to just so that everybody has a turn, you know? All right, let's graph our new 1/2 altered. From 0, 0, from the vertex, I'm gonna go over 1, up just a half. Over 1, just up a half. So that's like not even, yeah. And then over 2 and, wait, there's an error. Okay. Over 2, up 2. This is going to be wider parabola. Okay. Remember, this is my A on the front. The Y value is multiplied by my A. And this is normally what we see, okay? This is a normal standard parabola. The A is in the appropriate spot before the bracket or parentheses. When I get to 9 and 10, it's a little bit different because my A is inside. So it looks like this. Either A times X or Y equals, it could be like AX squared, something like that. It could be like that. And what I do is my X value is multiplied by the reciprocal 1 over A. And that's the rule. Because my A is inside the bracket, it's in a totally different location, which is not normal. This is a very unique kind of problem. I multiply by the reciprocal. So I'm going to look here and notice that my vertex is still at 0, 0 for both of these math problems. My 2, the reciprocal of 2 is 1/2. And I'm supposed to multiply the X value by 1/2. So stay with me, guys. Let me show them. If this is my standard table of values for a absolute value, ready? Absolute value. -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. That's just my parent function for absolute value. It's Y equals the absolute value of X. My new, remember, the reciprocal of 2 is 1/2, and that's going to be multiplied by my X term, and then Y stays the same. So what I should do is actually make this look a lot better and say that the reciprocal of 2 goes right there. So the reciprocal of A gets multiplied by the X value. So I actually don't do too much differently because my X value now gets multiplied by 1/2. Ready? That's 1/2 times -2. 1/2 times -1. 1/2 times 0. 1/2 times 1. right? 1/2 times 2. Okay. -1, -1/2, 0, 1/2, and 1. So write that down. X value changed, Y value didn't change. 2, 1, 0, 1, 2. Okay. Now I'm going to graph both of them. So first, I'm going to graph my 0, 0 from my parent function. Parent function is absolute value over 1, up 1, over 2, up 2, over 3, up 3, over 4, up 4. So go ahead and just make those points. It's a V-shaped. Okay. That's my parent function in pencil. Parent functions are always going to be in pencil. Now, let's do my new absolute value of 2x in pink. So from 0, 0, check it out. From 0, 0, you guys, I'm going to go 1/2 in both directions, up 1. 1 in both directions, up 2. From my 0, 0. 1/2 in both directions, up 1. That's like inside my pencil. Obviously my vertex is a point. Then for my vertex, I'm going to go 1 in both directions, up 2. So this is more narrow. Example 10 is me. What's the reciprocal of 1/2? Just someone tell me. The reciprocal of 1/2, I'm going to multiply by the x value.
2.
Someone, anyone? Ryan L.
The reciprocal of 1/2 is 2.
Yep. So it's going to be 2x comma y. Now, due to time, I'm not going to graph this all the way, but what it looks like is, like, I'll just do 3 points, -1, 0, and 1 for my parent function. Well, if I'm supposed to multiply only the x values by 2, then this is going to become 2 times -1, right? 2 times 0, 2 times 1. My y value does not change. Y value does not change. 1, 0, 1. So when you graph, you'll see that the changes make this become a wider graph. I want to get to 11 and 12 because those actually are really, really important because they've got lots of transformations on them. And that's where I want to spend our energy. Okay. When my vertex is not at 0, 0, that's what we're talking about now. My A is here. That has the ability to stretch, compress, what else? The H tells me whether I go left or right. My K tells me whether I go up or down, right? Remember how my opposite sign is in here? I'll put OPP, opposite. Okay. The vertex is what we need to pay attention to first. All of the other problems that I just did for you, the vertex was a 0, 0. So it was easy. So now I need someone to tell me, for example, 11, what's the vertex on example 11? Just real quick, some of you, I'm looking at your ceiling. I don't want to see your ceiling at all. So like Erin, I need to actually see you. And Mackenzie, I can't see you. I just don't want people to be like walking out of their room and then they never learn any math. Some people might do it. Okay, vertex, I'm sorry. What was the vertex for number 11? HK, guys, HK. You have to do a virtual hand raise. Jet. Maybe your mic is not on.
-3, 2.
Oh, I don't like -3 because remember how it's the opposite sign?
Oh.
So it's, what is it?
3, 2.
3, 2. Can you guys go ahead and mark that right now? 3, 2. 3, 2. Something's going on with this A. Check that out. It's a negative. Downward. Okay. So that means that I'm going to base everything off here. My parent function of a graph, if it's negative, downward is going to be -2, but you go down 4. -1, down 1. Your 0, 0 is still where you start off at. That's like your start. And then 1, down 1, 2, down 4. I'm going to graph my parent function first because you've never seen a downward parent function. Without any transformations, the graph of y equals -x² looks like this. Starting at your vertex, you go over 1, down 1. I go back to my vertex. I'm going to go over 2 in both directions. Down 4. This dot that my pencil's on is 5, -4. This dot that my pencil's on is now here 1, -4. That's the parent function of a downward facing parabola. So remember, I'm going from my vertex is how I'm doing my movements. Over, down, over, down. I'm done with my H and my K. Now I care about the -2 right here. That's going to change just like I did in number 7. Multiply your Y value by 2. X, 2Y. So remember, we're going downward. I don't want any positives in my Y values. We're not going up, okay? Here's my X. So if my Y value was a -4 in my parent function, I'm going to multiply that by a A negative 4 times 2, negative 8. A negative 1 times 2, negative 2. A 0 times, okay, well, duh. A negative 1 y value times this 2, negative 2. Negative 4 value times this 2, negative 8. So, ready? From your vertex, you're going to make your movements 1 in either direction, 2 down. 1 in either direction, 2 down. Here we go. 1 in either direction and 2 down. Ooh, look, x-intercepts. Hey, x-intercepts. 2 in either direction, 8 down. 8 down? Oh my goodness, guys. And obviously your point at the vertex is also there too. So I'm gonna go, and there is my transformed f of x equals negative 2 times the quantity x minus 3 squared plus 2 with an h and a k and an a. Example 12 has another vertex that's different, and it has a 1/2. Okay, I gotta say it right. Isha?
Yeah, it's Isha.
What's my vertex?
Your vertex would be 1, 4.
It would. Over 1 up 4. Vertex for both. I'm gonna do my parent function, and I'm gonna do parent function. Ready? Hey, it's absolute value. This is different. Absolute value is like every number itself. Negative 2, 2. Negative 1, 1. 0, 0, 1, 1, 2, 2. Okay? My y value gets multiplied by 1/2. Because 1/2 is my A. A. Okay. So now I'm wanting new volunteers. Your X value is going to stay exactly the same. Let me write them in right now. Tony, I see you. Hold on. Okay. 1/2 of the value of what X is. So Tony, oh, I see you. Troy, I'm so sorry. Troy. Sir, 1/2 of 2.
It would be 1.
Good. Rena, 1/2 of 1. This one right here.
1/2.
Yeah. You guys could put 0.5 as a decimal, or you could put 1/2. Okay. And that was, okay, got you. Romisa, I saw your hand up. 1/2 of 0.
0.
Julian, 1/2 of 1.
0.5.
And then obviously Kim, 1/2 of 2.
1.
Okay. Go ahead and grab both of them. Please do them in different colors, you guys. You need to be able to see the difference, okay? Nadia, do you have a question or were you volunteering? From my, oh, okay. This is upward. I knew it was upward because it's a positive 1/2. From my vertex, go 1 in, this is parent function, guys. 1 in either direction, up 1. 2 in either direction, up 2, etc. 1 in either direction, up 1. Back to your vertex. 2 side to side, 4 up. Oh, just kidding. This is an absolute value. 2 in either direction, side to side, 2 up. Pardon me. Okay, V-shaped, right? Pink. From my vertex. 1 in either direction, up 1/2. 1 in either direction, up only 1/2. Not even to the. And then from the vertex, 2 in either direction, up 1. So it's wider. Wider. You guys are doing good. What questions do you have so far?
So for each graph, the parent function, from the vertex, you move right or left, the same distance.
Yep.
Okay.
Now again, this is my method of teaching you. And there is another method, but I think this way is nicer. So I chose this way. So let's look at, we're going to skip 13 just because in time what am I at? I don't think I have time. No, I don't. Okay, we're going to do a matching on number 14. There are 2 that I'm going to give you as freebies that I think that you need to know because I don't think you'd guess them. I want to give you G. Oh, can you please number on the right-hand side? Can you go 1, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 8. It's easier to do matching when it's like that. Okay, I want to let you know about G. G is one of those weird ones where the A's inside. Anyways, G goes with 6, like a G6, like a G6. Because I like music, so I have songs for everything. Okay, then the other one I want to give you is F. And F goes with 8. Because see how it's negative? F, negative A, negative in front, that's an x-axis downward, right? I want you guys to help me with the others. So that means that F is an 8, G is a 6. So you guys work on the others. We have like 4 minutes. Go ahead. Okay. So here we go. Can I have help with number A, letter A, Chisholm? Chisholm, A.
Five.
What?
5.
Yeah. Yeah. Okay. Can I have Ella?
4.
B4. You are right. It is B4. Sid, what is C?
2.
Yep. I need a D and I need an E. New people. Isha, I've heard from you today. New people. Hannah. D, Hannah. Hannah, are you there for D? Do you want to do it or no?
Yeah, I'm here. Can you hear me?
Oh, no, I haven't been able to hear you yet. So an X minus 4, what is D?
D is 1.
It's not a reflection. This minus 4 means a movement one way or the other. Let me go to Jerome.
D is 7.
D is 7. Because even though it's a minus 4, it's the opposite sign. Okay, and then, ooh, E is hard because it's got a negative X inside, but it does do something. E and H. I need E and H. No one. Crickets. Ah! Okay, check this out. The stretching means, so H is going to be 3. And the reason why is because that number 4 is a stretch. So this negative X, that's going to be a reflection across the Y axis. We actually haven't seen that yet. I've never visually shown you a function that, I think we did one in page 1, but it was a straight line, right? I didn't have you write it in this format. So that's something that we'll do in a second. So, or E is number 1, sorry. Okay, so your homework is on Pearson, you guys, all right? And Pearson is a computer program, which means it's not necessarily going to grade it perfectly, and it might make a mistake, and it might think that you might not like how it grades, is what I'm saying, okay?